All right, here we are. So guess what? Right now, we're going to do a video on virtual networking. There's a lot to learn, so we're going to get started right away. So first off, virtual networking. Yeah, it's the abstraction of network resources from the underlying physical network infrastructure. A virtual network is the logical representation of the physical hardware, such as the switches and the routers that make up the infrastructure. You probably could have put that together yourself, but check it out. Virtual networks are going to reside on an abstraction layer, each with its own workloads and security. Now, while the virtual networks are isolated from each other, they can broadcast messages to each other via the virtual overlay network, without the messages having to pass through the underlying physical devices. Right? So virtual networking uses the power of software to abstract network services from the underlying infrastructure and then connect network components in an overlay. Each network node is abstracted into a virtual entity. This abstraction enables network administrators to make configuration changes virtually without even touching the physical devices. Sound good? Well, with virtual networking, the physical networking part, which comprises the routers, the switches, and all the other devices, doesn't change. Instead, see, an overlay provides a virtual path or tunnel between devices and through networks. This overlay enables a programmatic approach to networking that eliminates a tremendous amount of infrastructure and redundancy. So, for instance, if an organization wants to segment sales data and keep it from intermingling with manufacturing data, it's going to need two separate physical networks, yeah? But with virtual networking, definitions for sales and manufacturing could be created on the same physical network, and data in motion can be kept separate. All right, so a network's hardware devices usually define the three common types of virtual networks. A virtual private network, or VPN, it's going to use the internet as a transport, connecting two networks or connecting remote clients to central networks. VPNs create a secure, encrypted tunnel between two endpoints, ensuring privacy by obscuring traffic. So through a VPN, all network services on either side of the connection are presented as local services, but in between, they're hidden. A virtual LAN, or a virtual local area network, VLAN. This enables the segmentation of devices or endpoints within a network, delivering better security and management through virtual segmenting of traffic. VLANs tag network traffic at layer 2, encapsulating the packet so that the traffic only moves between the VLAN-tagged ports and devices. Now, up to 4,000 VLAN segments can be supported on a network. A virtual extensible LAN, or VXLAN, can create the same type of virtual network as a VLAN, but takes the VLAN concept a little bit further by encapsulating the media access control address in the user datagram protocol. See, so where a VLAN is defined over switch ports, a VXLAN creates virtual endpoints within switches or other layer 3 devices. So this enables a VXLAN to provide layer 2 functionality while existing on layer 3 at the IP, or Internet Protocol address layer. See, VXLANs deliver greater flexibility than VLANs and can scale up to, I hope you're sitting down for this, 16 million VXLAN segments per network. So these three examples of standardized network virtualization are all deployed on top of existing network infrastructure, such as routers, switches, and cabling, right? Now, another class of network virtualization is a bit more proprietary, and it happens deep inside a hypervisor that's running virtual machines, or VMs. A hypervisor can create its own virtual network, either an internal virtual network that enables communication only to those VMs local to the hypervisor, or an external virtual network that enables communication beyond the hypervisor to the rest of the network. Sounds pretty good, huh? Too good to be true? Check it out. Virtual networks provide key benefits to networking, including some of these: management. So virtual networks provide better access management by segmenting and joining devices virtually instead of managing these components only physically. Security. Better security is established by segmenting traffic and restricting access by groups, individuals, or devices. Simplification. Virtualization networking represents hard-coded and rigid network routes with simplified reduced paths that optimize access. IP mobility. VMs can be moved across a network easily to different hosts while maintaining their IP address, which aids disaster recovery and load balancing. Now, of course, with all the benefits are going to come a few, perhaps we'll call them challenges. So despite those many benefits and many more that you can imagine, the potential challenges will exist, and I'll list a few here. Extra layers of management, right? So the management of the network occurs at both the physical and virtual layers. Troubleshooting. And much like the management challenge, troubleshooting also happens at both the physical and the virtual layers. Potential security exposure. Now, the negative effects of misconfiguration can definitely be amplified across a wider set of devices or users. You follow? So, you ready for some examples of virtual networking? Here's a few. Load balancing. Yeah, so in order to maintain a more optimized traffic environment, many organizations rely on a load balancer. Virtualizing resources makes it much easier to address balance and move traffic. Hypervisor virtual servers. Yeah, virtual platforms like VMware, Hyper-V, and Xen all virtualize networking resources within the hypervisor and externally for VMs that are connected to the rest of the network. Cloud computing. Connecting data centers to cloud-based applications generally demands some level of network virtualization, especially in environments where an application may live in multiple cloud zones for redundancy. Software-defined data centers. So the SDDC strategy relies on network virtualization to create, at the data center level, a completely flexible pool of compute resources that can be dynamically deployed and reallocated based on need. All right, so now you know more than you did before about virtual networking. I know you're going to put it to good use, but for now, we're going to wrap it up. I'll see you in the next video.